way. So we're going to start taking a look at evaluating and graphing some things with polynomials. First thing we're going to do, because I just know how much all of you love dealing with the book. Okay, we're going to scratch that out, and the worksheet that you picked up, that'll also be on the website if any of you are watching this later. But this is now going to be our assignment. And again, get your date up there. That's always a good thing to help remind you, especially when we start getting towards a homework check on what it is, where I'm trying to find it. But what we're going to be doing today is letting the calculator help us on a couple of characteristics of a polynomial. But we're also going to use a pattern that develops here to give us an extra option, because the more options, the better to find us one that's going to make us feel a little bit better towards it. So the first thing we're going to do with polynomials today is figure out how we discuss them, what names we give to them. So when I talk about something, you're not like, what? What's he talking about? So what I'm going to attempt to do here to make this a little bit simpler is, depending on if something has a degree, okay, and this is based on the exponent you see. And actually, let me take that a little further. Based on the largest exponent that you see. So when we're looking at some of these equations and expressions today, I can't just assume that the first exponent I see is the one that I use for the name. I got to look for the biggest one. And we'll talk about how we make sure we do that here in a little bit. So when we talk about something that's degree 0, you're like, do we see that very often? Not really. We call it a constant term. A lot of times it'll be something like just a number. So like if the only thing I see there is f of x equals, or y equals 8, or some other number, that would be a constant. I should put in y equals here with it. Okay, if it's linear, so if I had like y equals 3x, because again, we know that if I don't see an exponent, we assume there's a 1 there. So I see the x to the first, well, it's going to be linear, it's going to make a line. We've dealt with those. Quadratics. So if I had like y equals 4x squared. Again, I'm seeing, okay, the 2 is squared. Quadratic, okay, the U-shaped things that we've graphed before are parabolas. So that would be an example of those. And it just continues to keep going up. So if I have something to the third power, that's called a cubic. We're going to start seeing some more graphs of those today. Those are kind of funky looking. They look kind of like snakes, but they're going upward as they're doing it instead of going side to side. And then these last two we don't see a lot of. Okay, we're going to see some pictures of them today, but we don't do a whole lot mathematically with them. They're called quartic and quintic. The way I tell people to try and remember quartic is it's like quarter, okay? And how many quarters are there in a game? 4. How many quarters are there in a dollar? 4. And so that kind of helps me remember what that one would be. And then 5 is the last one we actually have a name for. We call it quintic. Now that one can be a little trickier to have a little clue to remember. Besides, it's the only one that we really don't have a connection with here. And then the rest of them we just call polynomial of degree and put it out there. So like if it's to the 8th, we just call it polynomial degree 8 or polynomial degree 10. And don't get into a bunch of the fancy names. So when we're trying to describe these, there's a few things we can do with them. So first, we're going to see if something's a polynomial. Well, these all are. I'll help out with that. And then we're going to write it in standard form. Standard form. Largest to smallest degree. In other words, it may not be in the correct order. It may not be in order from largest to smallest, and we may have to do that at first. But sometimes it may be. but that's going to determine some other things for us. We got to make sure they're in order, even if we're not necessarily asked to do that. So when we get to standard form here, I start looking through here, and I'm looking for the biggest exponent. Well, when I find it, that term is going to be written first, and then whichever exponent comes next in order, I'd look for a third, but I don't see one. And I'd keep going until I got to my constant term, and then I'm done. So 4, then 2, then 0. My degree is just my exponent on my first term, once I have it in standard form, that is. Type, again, if you need to use the chart here at the start, there's nothing wrong with that. But again, 4 is like a quarter, so we'd write quartic. And then the one thing we haven't talked about yet is this thing called the lead coefficient. And so the lead coefficient is just the number in front of my first term once it's in standard form. And this is especially the reason that having something in standard form is so important. Because if I wouldn't have put it in standard form, I'd have written that the lead coefficient was a half, and that wouldn't have been true. So that's what we're basically looking at with these. So I won't put you through every single one. Okay, let's see. Let's go to the ones that keep getting mixed up here. Let's jump down here to 3, let's say. Okay, which one of my terms is going to go first here for number 3 when I'm putting it in standard form? Or is it already in standard form? Yeah, the video's still working. I'm just waiting on them. Which one of those terms has the largest exponent? Needs to be at the start. Okay. So, got my 2x to the 5th. Then I go looking for the next biggest exponent. And I just kind of keep, working my way down here. Once I do that, now everything's set up for me to do everything else, because it's all going to be based on this first term now. So my degree would be 5. My type would be quintic. And my lead coefficient would be 2. So those are the types of things that we're trying to look for. So one last one, this last one, because there's some funky stuff going on down here. So as I'm looking at this last one, I look through, I see my biggest exponent. And yes, pi can be a coefficient. Strange, but true. I go to my x term. And then my constant at the end. Again, once we're in standard form, which is always a good idea, I can get my degree. My type, which is based on that exponent, would be quadratic. And yes, pi is a number, and it can be a coefficient. And so we're good and set on that. So this is more about naming things, and when I'm using words and stuff like that, that we make sure that we're all saying that it's the same thing. Once we get there, we can actually start doing some math with it. So one way to evaluate a function is to use direct substitution. For example, we might have a function, and let me just make a note here. F of x is the same thing as saying y equals. It's just a different notation that we use in here. We're kind of getting more into big people math, so we don't use y equals as much, but it works the same way. So when this one says we're going to evaluate at x equals 3, that just means take this 3 and plug it in everywhere you see an x. So instead of just saying y equals, sometimes we may say f of 3. It doesn't mean we're solving for f. It just means, hey, the number that's in the parentheses, I'm going to plug that in everywhere that there's an x. Okay, so this is just a label for y equals. Okay, nothing to solve. And so I'd assume most of you at this point then would go to the calculator and type this in. Now again, if it's been a little while since you played with these, this is my exponent button here, my little caret here on the right. And it's just going to be important if you're on one of the classroom calculators that once you get here, you hit the right arrow to get it back down. Bless you, because otherwise, you're going to have a really large exponent here. And so again, once we're done with the exponents, we right arrow. Oh, I see what happened. Now, you might be like, what? I did a boo-boo, and I'm sitting there going, that's a really big number. Oh, kind of forgot the symbol in there. That's always a good-looking thing when you're posting things to a website and you're a math teacher here. Gracious. It just shows that sometimes it's easy to be careless when you're kind of just rolling along here thinking, I did it again. Gracious. I wish I could say this is purposefully me trying to just be a funny guy to prove a point. It's not. It's just Monday morning. Okay, now I'm going to double check again to make sure I haven't done anything else funny. Nope, that looks better this time. That's better. Okay. So whenever we're asked to evaluate, and again, that may be saying them giving you an x value. They may just say, and I'm actually going to write that for number 6 here. They may say, find f of -4. In other words, plug in -4 where the x is and tell me what the answer is going to be. So we've got to be ready for the language to change on us a little bit. So there's an x. So we're going to plug that -4 in there with parentheses. And then we're going to crank an answer out. So if I punch that in the calculator, I can get my value. But there are some things I'm going to have to be careful of. And I'm not necessarily going to tell you that you should go to a calculator on everything. Like number 7's a good example. I could mess around with the calculator, try and get an absolute value up, but I really don't need to. It's just going to cause me more trouble. So here, okay, I'm going to plug in the 1 for my x. Now, 1 minus 2 is -1. But this is where I've got to remember, but what does an absolute value do to numbers? Makes them positive. So this is really 3 times +1, or 3. Okay, I got to keep those types of things in mind. Those are things I need to know. And get me to my answer there. And then this last one is on there to know the importance of parentheses. I'm going to write that in here. So here, when I'm plugging my -2 in, whether it's to an exponent or it's just, plain old -2 that I get in there, it's going to be critical that I have the parentheses. Because if I don't, I'm not going to get the right answer. Because the calculators are pretty smart when it comes to this stuff. So again, I just plug that in, I type it, and I work it. And again, yeah, there's a thing mentioned here about using the store function, but seriously, for the amount of numbers we're plugging in, they're not huge, long expressions. If they were, that might be a little more applicable. But in this case, not quite so much. So we're not gonna really concern ourselves with that. Any questions on our substituting before we actually get into the pictorial part of this? Okay. So as we head to the back, we got one more thing we're going to kind of discuss here. And this is called end behavior. Okay? So what we're trying to say is what's happening to the graph as it moves from left to right. And this is going to look real complicated because there are going to be all these funky things and all these infinities and stuff. But we're going to try and keep this really simple. Okay? So here's basically what I tell people to look at. When we're looking at a graph, okay, we're going to draw a little sketch over here. When you're looking at a graph, as you move to the right on the x-axis, you're heading towards positive infinity because the numbers get bigger. When you're on the x-axis and we're moving to the left, we're moving towards negative infinity because the numbers are getting smaller as I go to the left. And the same type of thing happens with my f of x, which I'm going to refer to as here instead of y. As we go up on the y-axis, f of x gets closer and closer to positive infinity because the y values are getting bigger. And on that same y-axis, as I go downward, we're rolling on the negatives. So when we do end behavior, we're always doing end behavior from left to right. So when I look at a picture, okay, this basically says y is heading towards something as x heads to the left or as x heads to the right. We can think in our heads of it like it's English, left and right, but we have to write it mathematically. So here's what we're going to do. We're going to look at a picture, and we're going to kind of sketch them on these first couple, but then there's some ways that we're not going to have to necessarily do it that way. So we need to get to y equals, and we're just going to type in the expression, okay, 4x. Now hopefully we kind of got an idea what this is going to look like. It's just going to look like a line. So we don't have to have a picture that's real accurate. We just need kind of a sketch. So I kind of look, I'm like, okay, draw a sketch. That's fine. So now I'm kind of looking at this, and I'm going, okay. So my end behavior little expression is always going to look like this does. So I'm going to have 2f of x's and then I'm going to have this x, but my x's, the nice thing about the x's, they're always going to be the same. One's going to go to positive infinity, one's going to go to negative infinity. But what I'm going to want to do is I'm going to want to take a look at this, and I'm basically going to be doing two, at least I think it's only two, fairly simple things. Once I get this written, sort of like we did up here, I'm just going to put my L and R in here to kind of get me thinking about it. But here's the other thing I'm going to do. So remember, this says as x goes left. So I'm going to look on my graph and I'm going to find the arrow that's on the left. Okay? I'm going to circle that arrow first. Is this arrow going up or down? Well, it's going down. Well, when we're looking at the y value and it's going down, it's going towards negative infinity. So this first line says y goes down as x goes left. We're going left, we're going down. Okay. So then, well, what happens when x is going to the right? I find my arrow to the right. I ask myself, what direction's the arrow going? Up. Okay. So when y is going up, that's going to positive infinity. Okay. So this says y goes up, yes it does, as x is going to the right. And even if you need to write things like U and D for up and down, just because you're thinking about it in English before we speak math, that's an okay thing to do. And I'd suggest this is probably going to be the easiest way for most of you as we're doing these, is to just take a second off to the side somewhere. We'll make a little sketch of things. And you'll even get to a point, if you really are looking at these and doing them, that you'll probably be able to sketch them without even typing them in here. Negative 4x squared. Okay, let's see what we get. Parabola, opening down. Again, we're not looking for perfection. We're just going to sketch that in. So again, if I'm doing end behavior, this part will always be the same. The x's will always have 1 to negative infinity and 1 to positive. And again, I do that whole thing just putting the letters to remind me, okay, what direction are we going here? So as x goes to negative infinity, maybe even I put the infinities on the graph too, I don't know. So as we're going left, find my left arrow. And the only question you've got to ask yourself is it going up or down? If it's going down, we put it to negative infinity. And then I do the same thing for my second sentence here. As x goes right, find the arrow on the right. What direction is it going? Down. Put negative infinity. I'm done. And that really is all that we're doing as we mess with these. It's just going to be, as I go left, as I go right, what direction am I going? Always do the x part first, because that is going to be the easiest one to work with. This time our cubic, okay, that's what I meant when I was saying it's kind of snaky looking. Get those on there so I can kind of visualize what I've got working here. And again, I'm going to look and I'm going to say, okay, this x is heading to the left. So we're heading towards negative infinity here. All I care about is that arrow on the left side. It's going up. Up is positive infinity. And then I look at the other side. As x is going to the right. Check out the arrow. Arrow's going down. Down's to negative infinity. And I'm just sort of looking at them that way. Issues so far, because we only got one tiny little piece left to add, and we're going to be ready to roll here. Nope, we're just sort of going with the flow here at the start of the week. All right. So finally we get down here, and we're like, all right, what crazy other thing can he give me here to do? Here's one tiny thing we're going to change here, because we're going to talk about domain and range. When we're talking about domain and range, when we go to do our sketch, we're going to want to be a little more accurate than we were when we were doing end behavior, because there might be some certain points that are going to be important here. So this time, we'll use the chart to kind of help us a little bit. Even though I bet I got some things I can do to kind of help us out here. So if we go to y equals, we've got our quadratic, x squared plus 3. We can still look at it first. Okay, there's my parabola. Whoa, that's way out there. back to earth here. And basically all I do when I try to pull these up in the chart is just find some numbers that I'd actually be able to fit pretty easy into my graph. So like 0, 3 fits. Doesn't have to be a ton of points. So I get my parabola sketched in. And we'll start with the easy part. The easy part is going to be my domain. And you're like, why is that the easy part? Because no matter what graph we have, linear, quadratic, cubic, quartic, doesn't matter, your domain is going to be infinite. Because all of these graphs are going to go forever to the left and forever to the right. So that's good news. Now my range, I'm going to have to think a little bit. Because remember, when we're doing range, that's going to be bottom to top. Move that up a little bit. So when I'm going to graph this, I do notice that it goes up forever. So I know it's going to go to infinity, but it doesn't go down forever. The bottom of my graph is right here at 1, 2, 3. And so the range is the part that I may have to think a little bit, depending on what the picture looks like. But again, that's why we've got these. That's why I've got, the lists of different apps and things you can get for the phone if you want to go that route when you're doing these. So it's a little bit easier to work with. So let's play with another one here. Kind of take a peek at what this is going to look like. Okay, there's my funky little snake-looking guy. So, whoa, how did I get those big old parentheses? Wait a minute. Let's see if those big old parentheses not being there changes things. Oh yeah, that definitely changed some things. That looks a little more funky now. So let's see. If we kind of chart a few points here. Again, it doesn't have to be perfect. So -2, 9. -1, 0, 0, 1, 1, 6, and that's about all it's going to fit here. And again, I'll kind of look at the picture, make sure I'm somewhat accurate on my sketch. But again, it's a sketch. And so when I use that to look at my domain and range, all I'm basically going to do, my domain, again, I don't have to think. It's always nice when I can have a moment that I don't have to think. But when I do my range, again, I notice it goes up forever, so I got that part good. But here is my lowest point. And again, it's my y value at that point, so it's not -1. It's going to be 0. Just keep stressing yourself. Range, it's y, 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 y. Some of you may be saying, why am I doing this? Okay. So then our last one, let's see if I can get away from the glare. There we go. Again, keep remembering, right arrow as you do each of these to make sure. Make sure I type it in right, because I've had that issue a couple of times here. All right, kind of snaky. So we'll do second graph to look at our chart. And I get my graph working here. And this time, this graph actually makes life simple on me. You're like, how does it make it simple? Well, my domain continues to be infinite, but my range, if I look, it goes up forever, it goes down forever. And I can leave that on there. So again, as we're doing these, okay, the basic functions and evaluating polynomial review is the homework. We're doing just end behavior on the first part. So again, we're looking at f of x, and then the x heading to infinity into negative infinity. Now the one thing, and I'm going to do one of these with you here, we're going to have to add in a little something down here. Okay, write in standard form, biggest exponent to least. Name each polynomial by degree, so your linear, quadratic, cubic, blah, 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 and number of terms. Now that's not something we specifically discussed, but you've seen that before, even like in pre-algebra and things like that. But we'll kind of get an example here. Okay, when we're talking about number of terms, basically, there's four things that can pop up here. You can have a monomial if there's just one term. So like the whole thing there, like number 10, 7x squared, one term. It's a monomial, okay? But I could still name it a quadratic monomial. And it'll probably, as I start to write these, you're like, oh yeah, I've seen this before. Binomial, bicycle, okay? 2 wheels, 2 terms. And we'll talk about how I can determine terms here in a second too, because we're going to do number 7 since it's right there. We call 3 a trinomial. A tricycle has 3 wheels. So 3 terms gives me a trinomial. And then anything above that, we just call a polynomial. We don't have fancy names for it. We don't call it like a quadranomial or something like that. Cool concept, but not really. So what you're being asked to do in this section basically is going to be put them in order from greatest to least degree and then figure out these names. So like for instance, if I look at number 7, largest degree I see is 3. Take my signs with and just keep working my way down until I get to a constant. Once I get there, name each polynomial by degree. So 3 is cubic. And again, if you need the note sheet to get you going on this, that's okay. And then you're like, okay, so how do I tell number of terms? Every time you see an additional plus or minus between things, that's when terms separate. So like here, I got negative 4a to the third. Now I see a minus here. Okay, so that separates. 6a squared. There's another one. Plus 5a plus. So I've got 1 term, 2 terms, 3 terms, 4 terms. Okay, which makes this a polynomial. Or for instance, on number 9, I'll do the number of terms part. 10x squared minus breaks it up into pieces. There's 2 terms. So that's a binomial. Okay? So if you start reading something and then you see a plus or minus in the middle, that's when it starts a new term. And that's how we determine the number of terms that are going to be on there. And kind of work that through. Again, this is more just understanding the language, so we're all speaking the same language as we're doing this moving forward, with our graphing and things like that. And so then the back is just review of the stuff that we were getting into last week. But I do want to say one thing. We've got to be careful because some of you are actually making too much work for yourself. Because there's a difference between what's going on in 13 through 17 and then what's going on in 18 through 22 on the bottom. And the difference is, if there are signs in the middle, those are just combining like terms. We're not adding exponents. We're not multiplying coefficients. All you're doing at the most up here is if there's a negative in the middle, is that you're distributing that negative through, which is basically just going to be changing signs on these other values. The first one, since there's nothing in front of it, it doesn't change anything. And then you would go through and go, oh, so I've got 6 of them and I have one more here is 7. Or here I've got x squareds and x squareds. Negative 5 plus 7 is positive 2. I look around, I don't see any plain x's. One minus 3 is negative 2. And we're good. Okay, so that's all I'm doing up above. Down below is a different story. Down below, when I get to 18 through 22, now I'm not seeing pluses and minuses in the middle. So these are the ones where I'm doing a box or I'm doing foiling. So these are the ones where if I have exponents, I add the exponents. And if I don't, I'm just multiplying them together. Multiplying coefficients. Be careful with your signs. But once the box is full, once we've multiplied them, now it's just combining like terms like it was up above. So I look for my largest exponent. Like terms here. Again, we're just adding at this point. Don't multiply anymore. Negative 21 minus 7 is negative 28. Tuck my plus 49 on the end. So basically what we're going to do here is we're going to spend, today we did this, tomorrow I'm going to add one piece, and then Wednesday we'll kind of roll it back around and hit everything on a review again. Your first quiz will be Friday. I haven't changed the Friday thing up there yet. But your first quiz will be at the end of the week here on this stuff. We'll do a preview, and then we'll do that on Friday. So